Hello dear students, welcome to a new geometry class. Today we'll be talking about the distance between 2 points. If there are 2 points A, it has coordinates x1 and y1, where B, the second point, has coordinates x2 and y2, then the distance between A and B is given by a formula. This formula is called the distance formula. What does the formula says? The distance equals square root x1 minus x2 all squared plus y1 minus y2 all squared. If A is x1, y1, then the distance between A and x-axis is the absolute value of x1. And if A is x1, y1, then the distance between A and the y-axis is the absolute value of y1. Because as we said before, the distance cannot be a negative number of units. If A is x1, y1, then the distance between A and the origin point is square root of x1 squared plus y1 squared. Let's now move to example 1 and see how are we going to solve it. If A, 2 and 5, B, negative 1 and 1, find the length of AB. The length of segment AB is equal or the same as the distance between points A and B. Then AB equals square root x1 minus x2 all squared plus y1 minus y2 all squared. And here in the points, this is x1, y1, where here this is x2, y2. Then AB equals square root of 2 minus negative 1 all squared plus 5 minus 1 all squared. If you do your calculations, the right answer here is 5. Example 2, if A has coordinates 3 and 1, where B has coordinates 1 and 2, and C has coordinates 5 and 4, prove that BC equals 2 times AB. First of all, to find BC, we need to find the distance between points B and C. So we write here that BC equals square root of 1 minus 5 all squared plus 2 minus 4 all squared. Then BC is equal to 2 square root of 5. How to find the distance between A and B? The same rule, the distance formula. Square root of 3 minus 1 all squared plus 1 minus 2 all squared, which is equal to the square root of 5. As you can see here from 1 and 2, that BC equals twice or 2 times AB. Example 3, if the point A that has coordinates 8 and 9 lies on a circle whose center is point M that has coordinates 2 and 1, find the area of this circle and use pi equals 3.14. If this is the circle, you plot here point M in the center, and you plot point A anywhere. For example, if this will be point A. Point M has coordinates 2 and 1, where point A has coordinates 8 and 9. In order to find the area of a circle, the rule of area of circle is pi r squared. So we need to find the length of the radius. If we connect M and A together, so MA are forming a radius. So if you get the distance or the length of AM, this will be the radius of this circle. So AM equals 8 minus 2 all squared plus 9 minus 1 all squared. Then AM equals 10. This will be the radius of the circle. So to find the area of the circle equals pi r squared. The question told us that the pi is 3.14 times radius squared. So if you calculate this, the answer will be 314 unit squared. Example number 4, the question says, prove that the points A that has coordinates 4 and 3, and point B that has coordinates 1 and 1, and point C that has coordinates -5 and -3 are collinear. Collinear means that they are together on the same line. How to know that the points are collinear or not? If you do the calculations together, first of all, we need to find the slope of AB and BC. So, to find the slope of BC, the slope says y2 minus y1 over x2 minus x1. So, the slope of BC is minus 3 minus 1 over -5 minus 1. The answer is 2 over 3. Let's now get the slope of AB. The slope of AB equals y2 minus y1 over x2 minus x1, which is also 2 over 3. So here you will see that they both have the same slope and point B is common. Then points A, B, and C are collinear. Let's now move on to some notes. If the 3 points A, B, and C are not collinear points, then for sure they form a triangle. Let's now see some properties of this triangle. If AC squared is greater than AB squared plus BC squared, then this triangle is an obtuse triangle. If AC squared is equal to AB squared plus BC squared, then this triangle is a right triangle. If AC squared is less than AB squared plus BC squared, then this triangle is an acute triangle. I'm reminding you that when you do this, AC should be the longest side of the 3 sides. Let's now move to example 5. Determine the type of the triangle whose vertices are A that has coordinates 0, 5, B that has coordinates 3, 0, and C that has coordinates -3 and -2. Let's now find the length of the 3 sides. So the first side AB, we get its length, square root of 0 minus 3 all squared plus 5 minus 0 all squared. This one will be equal to square root of 34. if you get the length of BC, it is square root of 3 minus negative 3 all squared plus 0 minus negative 2 all squared, which is equal to square root of 40. And AC, its length is square root of 0 minus negative 3 all squared plus 5 minus negative 2 all squared. And the result is square root of 58. As you can see here, the longest side is AC. Then, to tell the type of the triangle, you go here and make AC squared in one side, and the other side you check AB squared plus BC squared. AC squared is 58, where AB squared is 34 plus the BC squared, which is 40. So here, this is 74 and this is 58, so the 58 is smaller than the 74. So this triangle is an acute triangle. Another example, let's now move to example 6. Find the value of A if the distance between the 2 points A7 and negative 2 and 3 is equal to 5 units. So here, we're going to say that the distance, which is 5, equals square root of A minus negative 3 all squared plus 7 minus 3 all squared. If you make power 2 in the both sides, so it would be 25 equals A plus 2 all squared plus 16. Then A plus 2 all squared will be equal to 9. So A plus 2 equals positive or negative square root of 9, which is 3. Then A plus 2 equals 3, or A plus 2 equals negative 3. Then A is equal to 1, or A is equal to negative 5. Let's now move to the evaluation part. Please pause the video, try to answer the question yourself. When you finish, play the video again to check the answer. First question says, prove that the triangle whose vertices are A, 5 and negative 5, where B, negative 1 and 7, and C, 15 and 15, is a right triangle at B. Then find its area. Let's now get the length of sides AB, BC, and AC. AB equals square root of 5 minus negative 1 all squared plus negative 5 minus 7 all squared. And it will be equals to square root of 180. BC equal square root of negative 1 minus 15 all squared plus 7 minus 15 all squared, and the result is square root of 320. To find the length of AC, AC equals square root of 5 minus 15 all squared plus negative 5 minus 15 all squared. Then it's equal to square root of 500. To prove that it's a right triangle, there must be AC squared must be equal to AB squared plus BC squared. AC squared is 500, where AB squared is 180 and the BC squared is 320. So here, as you can see here, this one is 500 and this one is also 500, so they're equal to each other. Then AC squared is equal to AB squared plus BC squared. Then this triangle is a right triangle at B. How to find the area now of this triangle? The area equals half times base times height. So the area is half, where the base is square root of 180, which is AB, times the height, which is square root of 320, which is BC. If you do your calculations, the area will be 120 units squared. Question 2. If points A, -1 and 4, B, 1 and 1, C, -1 and -2, and D, -3 and 1 are vertices of a rhombus, how can we find its area? First of all, we need to remember what is the area of a rhombus. The area of a rhombus is half multiplied by diagonal 1 times diagonal 2. How can we find the diagonals of the rhombus? The diagonals of the rhombus are AC and BD. So, to find the length of AC, it's square root of -1 minus -1 all squared plus 4 minus -2 all squared, which is 6. And the length of diagonal 2, which is BD, will be square root of 1 minus -3 all squared plus 4 minus 1 all squared, then it's equal to 4. To find the area of a rhombus, as I told you, it's half diagonal 1 times diagonal 2. So it's half, diagonal 1 is 6, times diagonal 2, which is 4. Then the area of the rhombus is 12 units squared. And now, my dear students, we came to the end of our session today. Thank you very much. Wishing you best of luck.